Phoenix has the capability to run R scripts as part of a workflow. Phoenix assumes that the external software R is installed and running properly in order to interact with it. Users can then run an R script within Phoenix utilizing data within the project and extracting R plots and tables back to Phoenix. As any workflow object, the status of the R script is tracked, and any changes to the input data renders this object out of date but easily refreshable. Before using an R object, one needs to configure the R connection within the Phoenix preferences. We select the Edit menu and navigate to Preferences. And then select the Preferences for R. The location of the R executable needs to be entered here. Users can use the Browse button to navigate to this file location. Optionally, if one wishes to develop R scripts using an environment like the R GUI or RStudio, the path to the executable can be placed here. The arguments field is optional and can be left blank. Any command line argument that you can use in your particular R application could go here. In this example, this argument indicates that Phoenix will name the R script as phoenix.r. A default output folder can be indicated in this box. And finally, one can select whether to create a unique subfolder for each run within the default output folder by selecting or unselecting this option. Once the preferences have been set up, an R script can be embedded within a Phoenix workflow. I will use an R script to create additional plots using the results of a Phoenix model object. For simplicity, instead of creating an R script within Phoenix, I will load one previously created. We use the Import File menu. We navigate to the location of the R script. I will open an R script file that was written to generate goodness of fit plots. Note that the R script has been imported under the code folder in Phoenix. Let's insert an R object in the workflow. We highlight the workflow and select the menu item Insert. Selecting the external software category, and then clicking on the R shell object. In this object, one can write an R script by writing code within the Phoenix text editor. This editor allows to type text, but if you want to take advantage of more sophisticated environments to run R, you can click on the Start button under the development environment if one was set up in the preferences. We will show this option later on in this module. In our case, since we imported a script, we uncheck the option Use Internal Text Object and drag the R script into the window. There are several ways to link data within Phoenix to be used by the R script. These options need to be indicated at the beginning of the R script code. In this script, the attach option is used. When using attach, the name following in parentheses is the name that shows up in the setup, and the name of the dataset that can be used by the script. Then, the syntax $WNL_in allows users to list the columns that the dataset should have. Notice that we request 10 columns and place a second number sign at the end. The pound or number sign or hash symbols need to be placed as shown. We click on the residuals item under Setup. And we see that the 10 columns that the script listed are in orange on top, indicating that these are required columns. One can then drag a dataset within the project into the mappings area. We will use the final results from a Phoenix object. We select the worksheet Residuals, which is the standard output for this object. The R script was written to request all the columns with their standard naming of the Phoenix residuals output, and thus, most of the data is mapped automatically. However, the expected ID column is not mapped because the subject identifier in this particular dataset was called XID. We map this manually. We confirm that all required variables are mapped. Let's take a look at the script. The script uses the residuals dataset from Phoenix to create some additional R plots. In order to bring these plots into Phoenix, image files are created at the end of the script. Notice that the script is asking R to create 3 PNG files, with the names shown in red. These images will be placed in the specified output default folder, and Phoenix will grab them and bring them into the results section. Let's run this R shell object that will interact with R to run whatever is specified in the script. Upon execution, the Results tab shows the 3 plots created by R, but now as part of a Phoenix object. We can see these graphs when we click on them. This project also contains the R data file, which is a format designed for use with R for storing a complete R workspace that can be loaded back by R. This file is provided because the option to create a workspace was checked. This file cannot be rendered here, but it can be exported or viewed within the preferred external R environment. The R login text format is also included, and the selected Phoenix settings are recorded. As mentioned, if the R script indicates to create files outside of R, then those files are automatically inserted in the Results tab of the R Phoenix object. The types of files that R can create that Phoenix can include as part of the output are as follows. For images, the supported formats are .jpg, .tiff, .emf, .wmf, .bmp, .gif, .png, .svg, and .pdf. The datasets and tabular form supported are Excel formats, comma-separated files, and tabulations with .dat or .txt extensions. Supported text output is any file with plain text content, such as the R log file. In the previous example, we saw how the attach command was linking data within a Phoenix project to the R script. However, if the source data is large, one might not want to import into Phoenix and instead might just want to point to a path location. I will now show you how to do this using a shortcut import. Let's insert a second R shell object. We select the Insert menu. Click on the External Software category and select the R shell. We will rename the object by clicking on it. We then drag the same R code into this new object. To edit this code within this object, we check the option to Use Internal Text Object, and click Yes to copy the code. This unlinks the code from the code folder. We delete the attach statement. When clicking Apply, we will see that the residuals item is removed from the setup. We now paste a different syntax on top of the script. The syntax number symbol phx_shortcut indicates that the type of file we want as a source is a Phoenix shortcut. The name in parentheses, my file, is arbitrary. This is the name that will appear in the setup to be mapped. The second line creates a dataset residuals that corresponds to the shortcut that will be mapped under the name My File. After clicking Apply, we see a new item, My File, in the setup. Only a Phoenix shortcut can be mapped in the My File setup. Let's import a shortcut into this project. We click the File menu. Then we click on Custom Import. Select the File shortcut option. We select the residuals, delimited file, and click Open to link this path. In the shortcut folder, we see that this file is not truly imported into Phoenix, but the path to the file is stored. Let's go back to the R shell. Here, we can drag the shortcut into the path. Now the R script knows what data source to use. Note shown here, we right-click and do a text replacement of the word ID to XID. XID is the column name for subject ID, and since we are reading the original data, we change the script to account for this new name. We execute this R script. And we obtain the same results as before. Finally, we will show a third way to read a dataset from a hard-coded location in the R script. We insert a new R shell and rename it. We drag the R code into the object as before. We check the Use Internal Text object to be able to edit the code. We delete the first row. We type in a code that simply reads the data from a hard-coded location. As mentioned, since we don't have a chance to map column names, this time, instead of changing all the code, we will simply define the variable ID as the column XID, so no other modification needs to happen in the code. We execute the object, and we obtain the same results as before. In this last section, we will see an example of using an R development environment. We will show RStudio, but other preferred environments can be used. Let's insert a new R shell. We start by selecting a source dataset. We click on the Select Sources button. We navigate to the model residual output. Now the source has been identified. We click Start to start the external R development environment that was selected in the Preferences menu. In our case, RStudio opens and we see that the source dataset and an R script are available. We click the R script. Phoenix has already entered the necessary statements to access the source data. Additional R code can be added in this environment to develop the script as needed. Once the script is ready, users should close this window or quit the session. To bring the script into Phoenix, select to save the workspace. Once in Phoenix, click to reload the script. The script now appears in the window. Click Apply and you are ready to run. The results are the same as before since we ran the same script. In this module, we have learned how to run our scripts within Phoenix as part of a workflow, and thus being able to track the status of the script. We have shown 3 ways of linking the input data to the R script. The first option allows users to use a dataset already in the Phoenix project. This utilizes the attach statement and the WNL_IN. The second option is to use a dataset that may be too large to include in Phoenix, but that you want to browse to. The second option requires that the dataset is selected as a file shortcut custom import. Using the phx shortcut statement allows a Phoenix shortcut to be mapped in the setup. The second option allows datasets to be quickly swapped as long as they are Phoenix shortcuts. The third option was to simply hardcode the dataset location in the R script. In addition, we also showed how an already existing R script could be imported and used within Phoenix. We also discussed how to develop scripts within Phoenix using the text editor inside the Phoenix R shell object. Lastly, we showed how to use your preferred R development environment, such as RStudio, to create R scripts, and then bring the script to the Phoenix R shell object.